Today we'll discuss the heterozygote advantage. But first, some background information.
Heritable traits are passed on through genes. Each gene carries two types or alleles and can be identical or different.
An individual is heterozygous when their two alleles are different, and homozygous when they are the same. Alleles can be dominant, meaning only one is needed to express the trait, or recessive, in which two are needed to be expressed. So why is being heterozygous an advantage? Heterozygote advantage is a major underlying mechanism for hybrid vigor, which is the improved or increased function of any biological quality in a hybrid offspring. A great example is the recessive genetic disease cystic fibrosis, in which a mutation in the CFTR gene alters the production of sweat, digestive juices, and mucus, and leads to chronic lung infections, gastrointestinal issues, and other side effects. Studies have shown that carriers of the CFTR genetic mutation do have an advantage over those who do not carry the gene. Individuals infected with certain diseases like cholera or typhus often succumb to an electrolyte imbalance and dehydration caused by severe acute diarrhea. At the University of Chapel Hill in North Carolina, mice with the cystic fibrosis genetic mutation were infected with cholera. None of the mice succumbed to dehydration as their intestines did not have the chloride channels to secrete fluid. Of course, these mice did have the actual disease of cystic fibrosis, which is not an advantage to survival in the long run. For a heterozygote, however, a balance is achieved. The carrier of the CFTR mutation will not have cystic fibrosis, but will have only half as many chloride channels as a non-carrier. This limits the amount of fluid lost to diarrhea in the event a carrier gets infected with a disease like typhoid or cholera. So how is heterozygosity advantageous to the population? Polymorphism, the occurrence of two or more clearly defined types, can be maintained by selection favoring the heterozygote. This mechanism is used to explain the occurrence of some kinds of genetic variability. Heterozygotes have both alleles, which is essential for there to be genetic variation in a population.